Okay, this is May 7th for the third distance learning packet. And we are continuing with our probability and statistics and scatter plots. And we have a graph given to us. We have a table that shows us population and years. And we're asked to graph this or plot the points, draw a line of best fit, and then identify the correlation or the association type. And then moving on to eventually finding the equation of the line and then making a prediction. So we have a blank graph. So look at our table and let's see how we need to set up our numbering. So remember, when we have time, that's going to be the x-axis. So that's years. And then y will be the population. So looking at the years, we have 1970, 80, 90, 2000. So that's counting by tens. And then it's 1 year increments after that. So let's see. And this is going to be a type of graph that doesn't necessarily start at 0 because we're not going to start at year 0. So we'll just start off at 1970. So maybe let's try this one at 1970. And then we'll we'll go 1980, 1990, 2000. And this would be 2010. Okay, so 2010 is higher than the number that we have, so that should work. So let's see if this can work for us. And then usually we put like this kind of a squiggle thing, and that just tells us that we skipped some numbers. So the origin is still the origin, still 0, 0, but if we were to use our same spacing, this line right here would be 1960, but really it's 0 for the graph. So we'll put that little squiggle to show that we skipped some spaces. Okay, going up the y-axis, it's all counting by tens. So I'm going to, let me just use each line. So 10, 20, 30, 40, 50, 60. Probably could have skipped every other line just to spread it out, but this is fine. All right, so let's plot these points. So 1970, let's actually label this first because there's something very important about our y-axis, and it says in thousands. So it's not 10 people, it's 10,000. So this is population in thousands. So 10,000, 20,000, 30,000, and so on. And then this is the years. Okay, so 1980 and 20, 1990 and 30,000, and 2000, and then 40,000, and then 2001 and 50. So 2001, okay, so 2005 is halfway. So 2001 is just past 2000, so it's about here. 2002 is 60, so it's really starting to increase a lot more quickly than it had been. All right, and then we need to, so that's the first part. So sketch it or graph it. And then 2, draw a line of best fit. And we want a line that goes, doesn't have to go through the origin, but we just want a line that goes through the data, kind of halfway through it. Maybe something like that. Again, use a toothpick or a piece of spaghetti. Again, just so you can put it on the graph, move it around, and you can see both sides. So we want to try to make it so that there's about an even number of the same number of points above the line as we have below the line. Okay, so that's our line of best fit. Okay, number 3, what type of correlation? So it's going up to the right. So think about slope. Is it a positive slope? Is it a negative slope? Okay, it's a positive slope. So this is a, let's just say it has a positive. So the choices are positive, negative, or no correlation. So this is definitely a positive correlation. Remember, we also use words like association or trend. Okay, 4, calculate the slope for the line through points 10, 1970. Actually, should be flipped around. So 1970, 10, so x comes first. But, and keep in mind, there are mistakes in these packets, definitely a lot of mistakes. And it happens. I mean, it happens in textbooks. I mean, humans make these things, so there are mistakes, and we just have to kind of think about what makes sense and do that. Okay, so the 1970, so this point here, I'm trying to put it in green, and then 1980 and 20. So this, we want the slope between these 2 points, not the line of best fit that we drew. So if the pattern continued like it started out, just every 10 years it increases by 10,000 people. If it kept doing that, we would have a point here, and there'd be a perfect line going through all those points. But because we had those jumps in population in a short amount of time, it moves the line, it pulls the line up towards those points. So we can think it's probably going to keep going, increasing like that. So that line of best fit will keep angling up more and more to account for those extra points. So that's why our line doesn't go through the first 4 points perfectly. But anyway, let's find the slope as it says. So it's rise over run. Okay, so we're going to go, we're going to go up and over. So how much do we go up? So slope equals rise. So look at the numbers, 10, but it's 10,000, remember, over 10 years. So be careful when you do that. So it's in thousands, so we have to use the full number. And then we just divide. Okay, so this would be 1,000 and what? 1,000 people per year. Okay, so rise is people, population, and then x is years, so people per year. Okay, now write an equation for this line. So the line of best fit is the equation that we want. All right, so let's choose 2 points on our line that we drew. And it's not going to be the exact one that goes to those points. So we're going to just do the best we can. Let's do that in light blue. Okay, so let's say I have a point here I'm going to use. I have a point here I'm going to use. And then we need the slope. And we do that. Okay, so how much do we go up? We go 50. So we need the slope. So 50,000. Right? From 10,000 to 60,000. It's 50,000. And over how many years? Okay, so this would be 2015. From 1970 to 2015. So from 1970 to 2000, that's 30 years. Plus another 15, so that's 45 years. Okay, so our slope, so just thinking about this, our slope is going to be, what do you think, a little bit more or a little bit less than what we found using those other 2 points? And think about that second point that we used for number 4 was a little bit lower than our line. So our slope should be a little bit more because it's a little bit steeper than the other one. So 50,000 divided by 45. Okay, so that's all ones. Okay, so we have 1,111 people. Actually, we don't even have to write that because we're trying to find the equation, so we just need that number. All right, now we need the y-intercept. So what is that? What do we think that's going to be? Where does it start? So that's the problem. We have no idea. So if we can make this graph a lot bigger, would this line actually go through the origin? So I don't know. We can't really write an equation. We don't have the y-intercept. If we assume it's 0, then our equation would be just y equals 1,111x. And that doesn't really work because if you think about it, if we substitute one of our values in, so let's substitute 2,000 in. Okay, so if x is 2,000, then it's not going to give us 40,000 for the population. So we need to kind of reconfigure our graph for this to make more sense. What we could do is, instead of putting the actual years, we could just say that this is 1, and then every 10 years would be, well, from 1970, so let's make that 0. Then this would be 10, 20, 30, 31, 32. Okay, so that would be okay. We could do that, and our starting point is 1970, but it doesn't say that. Usually it would say from, what's the equation from this particular year, but we don't have that information, so let's just leave it as this. It's fine. Again, this is just practice. As long as you can write an equation for a line, that's really what we're practicing here. And then number 6 is predict the population in the year 2000. Well, again, this is a mistake because we know it. It's right there, 40,000. So there's 40,000 people. So again, not a great problem, but if you do this, if you understand how to draw a line of best fit, how to plot points, how to write an equation, that is perfect. All right, and here we have another one of those balancing mobiles, and a little bit more complicated this time, okay? So again, I'll just kind of remind you what we did before, but this is a balance, okay? So there's 6 on this side and 6 on this side because the total thing is 12, and we're given that this shape is 5. So then can we figure out what the moon is? So it must be 1, right? Because 5 and 1 is 6. So this whole thing has to be 6. So this is 1. Then this also has to be 5. Okay. So does that all add up? 1 plus 5 is 6, plus 5 is 11, plus 1 is 12. All right, so that's it. So, work through these. If you have any questions, again, just leave a comment.